Hi everyone, welcome to this tool demonstration of Repackman, a tool to automatically repackage Android apps with arbitrary payloads. My name is Ale, and I will guide you through this demonstration of some of Repackman's capabilities. Repackaging of Android apps continues to be adopted by attackers that leverage the ease of decompiling, reverse engineering, and repackaging Android apps to graft legitimate popular apps with arbitrary, sometimes malicious payloads. Needless to say, researchers have been devising anti-repackaging techniques to counter this phenomenon. But in order for them to evaluate the effectiveness and applicability of their anti-repackaging techniques, researchers need access to repackaged versions of the apps they protect using such techniques. So there's a need for a technique, tool, or method that provides developers and researchers with the capability of generating repackaged apps on demand. Here's an example of how easy it is to manually repackage an app. Android apps can be easily disassembled to smaller representations as seen in the figure. Assume we wish to add the functionality in blue, which displays a toast message injected, to that of the original program in black, multiplying a random integer by 2. All what we need to do is merge both strings, and as seen on the right, and update the number of variables used by the new mixed code via the .locals statement. We implemented Repackman to follow this simple and effective operation. Repackman is implemented as a command-line Python tool that supports multiple operations, chief among which is that of repackaging. Given the path to an APK archive to repackage, the first step in the repackaging process is to extract the archive and disassemble its classes.dex file into a smaller representation as seen before using APK tool. This step also includes analyzing the app to retrieve details about its components and their internal structures. We use this information in the second step to identify possible locations to inject the new or the writer code. Such insertion locations are also dictated by the user via a command-line argument called deployment methods. In step 3, the payloads and triggers chosen by the user are retrieved from a database which contains smally templates of those code segments. Some of the payloads and triggers might need access to specific Android permissions. The tool adds the necessary permissions associated with each payload or trigger to the target app's Android manifest file. In step 5, the trigger and payloads smally representations are injected into the original app's code, and necessary changes are made to the mixed code, for example, like updating the .locals variable. Lastly, the modified code of the app will be reassembled using APK tool and signed using a private key supplied by the user. Now we demonstrate how the tool works by repackaging a simple calculator app with the delete contacts payload. In this example, we repackage the app using a mode that guarantees the execution of the payload by injecting it in the onCreate method of the app's main activity. So here is the app. As I said, it's a simple calculator. Let's do a simple operation here and check whether the payloads are in place, the contacts are in place. Now let's go to the terminal and run Repackman. So the app is decompiled, analyzed, the code is injected, it's repackaged and signed. Now let's just uninstall the old version of the app and install the repackaged one and go back to our app. Now notice it takes more time to load the display or to load the GUI to the user because it's actually deleting the user contacts. And let's make sure that this actually happened. Voila. Right, so that's Repackman in a nutshell. Thank you for watching.